Yeah. Students, good morning, students. How are you all? Right. Yesterday we have studied about how to check the correctness of an equation using dimension. Now, today we are going to discuss the derivation of a formula using dimensions, right? We can derive a possible equation of a possible physical event using dimensions. This is also working on the principle of homogeneity of dimensions, right? Every term of the equation of a possible physical event must have same dimension, right? This is the theory used in this case also. So today we are going to discuss how we can derive equation of a possible physical event, right? First of all, for an example, derive an expression for time period t. Derive, derive an expression for time period t of a simple pendulum, Simple pendulum we have already discussed earlier, which may depend upon, which may depend upon, depend upon, which may depend upon mass of the bulb, mass of the bulb, mass of the bulb, length of the pendulum, mass of the bulb small, right? Next, length of the pendulum, length of the pendulum, length of the pendulum is L, and acceleration due to gravity, acceleration due to gravity, right? Provided, if you are provided the conditions on which the physical quantity depends, then only we can derive that. In every question like this, on what factors the particular quantity depends, then only we can derive a equation of a possible physical equation, right? So in this case, we are discussing about a simple pendulum. Simple pendulum is nothing but we have seen simple pendulum yesterday also. This is a simple pendulum. If a bob means a heavy weight, that can be a spherical body. A spherical body is suspended with the help of an inextensible flexible string from a rigid support. This is a rigid support. This is the string, right? This is center of gravity of the center of gravity of the bob, bob. This has a mass m, and this much length from the center of gravity to the point of suspension is called effective length of the pendulum. When the pendulum is set into oscillations, it starts vibrating, and every vibration, the pendulum takes a fixed amount of time. That time is called a time period. So in this case, the time period only we have to calculate, right? Time period t of a pendulum, that is depending on length of the pendulum, and also it is depending on mass of the pendulum and acceleration due to gravity. Acceleration gravity also we have discussed. It is the acceleration produced on a body when a body is dropped from a certain height above the surface of the earth. It is denoted by small g, right? Its value is 9.81 meter per second square, right? This is about pendulum and all. Now we are going to derive the expression for that. In this case, you will first write the quantity to the equation of the quantity to be derived. T is directly proportional, like this you will write. So what are the things given? That is m. You will write mass, that's you will write m raised to a, you will write. You don't know what is a, b, and c. That you will get just now, right? It is depending on mass. So therefore you will write, put a what is called the power of mass is a, m L raised to b. Next quantity on which t depends is L raised to p, and g raised to c we can write. Am I correct? So first of all, the conditions you will write. That means t is depending on mass, length, and time. Applied with the certain powers you will write. This is the common procedure for deriving an expression for a quantity, right? Like this. So t is directly proportional. On t is equal to a constant k into m raised to a, L raised to b, and G raised to C also we can write. So this is the first procedure. So the conditions will be all conditions will be given in the question. According to the conditions on which are the quantities on which the body depends, the physical not depend, that will be written like this. T is directly proportional to M raised to A, L raised to B, and G raised to C. Accordingly, as whatever be the quantity, right? When the quantity is changing, this value may be changing. A, B, and A, B, C will be there, but this value may M, L, G, that may change, right? Sometimes in place of G, there will be T, right? And these values may change. Physical quantities may change on which this particular quantity depends. So this is the first way we have write it. T proportional. T is equal to constant K into M raised to A, L raised to B, and G raised to C. Now taking dimensions on both sides. This is time only. So the dimension of time is given as equal to M raised to 0, L raised to 0, and T raised to 1 we can write. Because this is only T. Therefore, the dimension of mass is 0, dimension of length is also 0, right? Now, coming to the other side, K has no dimensions. This is equation number 1 you can write. K has no dimension. But M, dimension of M is capital. The whole raised to A you will write, okay. Into capital, this the dimension of length is capital L. The whole raised to B you will write. And the last quantity is G. G means acceleration due to gravity. Acceleration due to gravity is acceleration only. Acceleration, everybody knows that is L T raised to minus 2. This whole raised to C also we can write. Am I correct? First of all, you write the conditions on which this quantity depends. Then you will write as an equation by multiplying the constant K. As A has no dimension, here K is a constant. That's right. Now we will distribute the powers. You will get that is M raised to A, L raised to B, again into L raised to B, L raised to C, L raised to C into T raised to minus 2C. That means the powers are distributed. Am I correct? L T raised to minus 2, the whole raised to C is equal L raised to C into T raised to minus 2C. Now L and C both are there. Therefore, A raised to M into A raised to N is equal. There is a formula here in laws of indices. A raised to M into A raised to N is equal to A raised to M plus N. Right? That is 2 square into 2 cube is equal to 2 raised to 6. Right? 2 square into 2 cube is equal to 2 raised to 6. That is the only thing. A raised same quantity. A raised to M into A raised to N is equal to A raised to N, M plus N. So here also L raised to B into L raised to is equal to L raised to A plus C, right? Therefore, this is equal to M raised to A into L raised to B plus C into T raised to 2C we can write. T raised to 2C we write. Very correct. So this is how we got finally. Now we'll equate the powers of here also 1 M, here also 1. If this equation is equal to this equation, then powers of the same quantities on either side will be same. What is the power of this? Power of M on the left hand side, that is 0. Therefore, the power of that in the right side is A. A must be equal to 0. In the same way, B plus C must be equal to 0. In the same way, minus 2C. Okay. Minus 2C must be equal to 1 also we can write. In that way, we can calculate A, B, and C, right? Now we can write, but A is equal to 0, you will write first condition. Again, next is what? B plus C is also equal to 0, we can write. Okay. Again, what is that, right? Right. Minus 2C. Minus 2C is equal to 1, we can write. Minus 2C is equal to 1, it means C is equal to minus 1 by 2. C is equal to minus 1 by 2, we can write. Am I correct? Okay. In this expression, if C is equal to minus 1 by 2 written, then what you will get? That is B plus minus 1 by 2 is equal to 0. That is B minus 1 by 2 is equal to 0. Therefore, B is equal to 1 by 2, you can write. A is equal to 0, right? A is equal to 0 and B is equal to 1 by 2 and C is equal to minus 1 by 2. Putting that in this formula equation number 1, putting the values in equation number 1, we will get T is proportional to or T is equal to K into M raised